Welcome back to the Cosmic Geologist, where today I'm going to reveal the crystals that we made in our crystal experiment part 1. So in part 1, we made crystals using stuff we have around the house, and this is a good lesson and good reminder that not all experiments turn out how you think they will. There were definitely some failures, or shall we say, learning opportunities.
You have failed me for the last time, Admiral.
I'm also going to be answering the question, did we make minerals or did we make something else entirely? I made crystals out of borax, sea salt, iodized salt, sugar, and calcium chloride, or pickle crisp. Each got its own jar and a place to hang out for a week or two. I left them a little bit longer than I wanted to. Life got a little crazy and I kind of forgot that they were in the corner of my office. So that may have affected our results a little bit. So here's what happened. The first unexpected result was the salt. Although if I'd really thought about it, it's not that surprising that it resulted in the way that it did. Here's the iodized salt. But this isn't surprising because salt commonly forms in an evaporative environment. So basically we created our own little desert, and the place that I live is really dry. It's no surprise at all that this happened in such an arid environment. And as you can see, absolutely nothing formed a pipe cleaner at all, because any crystal that would have formed on there would have been redissolved by the solution. So this does make sense that it would form on top, almost making its own arid little lake to evaporate in. And then we have the sea salt, which is very similar story here, but a lot less crystallization going on. So we have a little mini, kind of crystal. A little bit grew on the popsicle stick, but not much. And I wonder why iodized salt was so much better at creating cool crystals than our sea salt. Maybe it has to do with the impurities and there's just more sodium and chloride ions in the iodized salt. I'm gonna have to look that one up. So table salt is made of sodium and chloride ions, and it's also known as halite when it forms naturally. But unlike borax or sugar, halite doesn't love crystallizing deep in a solution. It prefers to grow by evaporation, like in dry lakes where water likes to seep up and then evaporates at the surface. So in our experiment, water wicked up through this paper, and then the water evaporated into the air and then left behind tiny cubes of salt. So even though the jar was full, the action, all of the crystallization was happening up top on this paper. So here are the borax crystals, and they made really big crystals very quickly. This is a good reminder if you're gonna do this experiment to make sure that your pipe cleaner is closer together, because there's kind of some gaps here I was hoping the crystal would fill in, but it kind of almost made like a little geode. The reason it's so sparkly is because it actually made great crystal faces. I believe it's orthorhombic. And that's what the light reflects off of, almost like mirrors. Super fun. Here's another example. I tried it again. If I were to do this again, I would make the pipe cleaner the same color as the dye that I put in. Lesson learned, just because you can almost see the coloration of the pipe cleaner through the crystal. And if you wanted a purple crystal, use a purple pipe cleaner. Wow, that's a tongue twister. So those were my successes for the most part. The sugar crystals did not work out. I really want to try to make sugar crystals. I think it'll look really cool. I must have done something wrong, maybe a different concentration of sugar to water. I know I added a lot of sugar and maybe not enough water, or maybe it has to be more evaporative type of crystal. I'm gonna look into it and try again. For the calcium chloride or the pickle crisp, that was far more exciting to actually make than the crystals ended up being.
Oh! I can do this.
About 4 hours after making the solution, I did notice a few little crystals kind of forming, but because I kind of forgot about them, they must have redissolved into the solution. So if you're gonna try that one, crystals, go ahead and take them out and put them on a drying rack. Otherwise, they'll just redissolve into the solution. So the big question is, did we actually make minerals or did we just make cool crystals? To answer this question, let's talk about what a mineral actually is. So to be a mineral, something must be naturally occurring, inorganic, meaning not carbon-based, solid, have a definite chemical composition, and have a crystal structure. So in the case of this borax crystal, for example, we have a lot of those boxes checked. We have a solid, we have an inorganic compound, we obviously have a crystal structure, and it has a chemical composition. But the kicker is, this is not naturally occurring. I made it in my house. And so technically, this is a synthetic mineral. You'll see synthetic minerals, they sell them at like museum gift shops, the ones that are super flashy and almost unreal colors, those are often synthetic minerals. To get the real deal, it has to be made in nature. Something like halite made in a dry salt lake, or quartz made in a magma chamber, or like a zeolite made in a volcanic vug or gas pocket. So unfortunately, these are just synthetic minerals, but they're still really pretty.
What we did create are the same conditions that Earth uses to create minerals. That's geology, chemistry, and kitchen wizardry all in one. So if you want to grow your own crystals, check out part 1 of this series to get full instructions, or check out thecosmicgeologist.com for a full tutorial. And tell me in the comments which crystal you liked the most and which one you're going to try to grow at home. I'm the Cosmic Geologist, and this is another story from the crystal to the cosmos. I'll see you next time.